we're going to be making the review video for section 12.2. That's chapter 12, section 2. And as always, we start with a learning target. Our learning target for today is to find the probability of independent and dependent events. Well, we need to define those two terms. All right. And so a compound event is an event that consists of two or more simple events. So it's two or more events, one occurs and then the other one occurs. Independent events, two or more events in which the outcome of the one event does not affect the outcome of the other, so they are independent of each other, they are not related. And dependent events, are two or more events in which the outcome of one event does affect the outcome of the other, and we'll do examples of both. Here's the first key concept, the probability of two independent events. These are independent. Independent events can be found by multiplying the probability of the first event times the probability of the second. So probability of A and B occurring is the probability of A times the probability of B. So we've got two spinners here, numbered 1 through 0. So there are 10 different possible outcomes on the first one, and there are 10 different possible outcomes on the second one. Says the two spinners below are spun. What is the probability that both spinners will show a number greater than 6? Well, numbers greater than 6 is 7, 8, and 9. So there are three numbers for this one that's greater than 6, and there's 7, 8, and 9. So there's three numbers for that one that's greater than 6. So 3 times 3 is 9. 10 times 10 is 100. So there's a 9 out of 100 chance that both of them are going to roll something or spin something greater than 6. Two spinners are spun. What is the probability that both spinners will show a number less than 4? Well, this first one has 6 different possible outcomes. 1, 2, 3, 4, 5, 6. And numbers less than 4, there's 3, 2, and 1. So there's 3 out of 6 chance of getting a number less than 4 on the first one. On the next one, there's 1, 2, 3, 4, 5, 6, 7, 8. There's 8 different possibilities. And numbers less than 4 is 3, 2, and 1. So there's 3 out of 8. If I look at this, I'm going to do a little reducing here. I'm going to say 3 over 6 is 1/2. 1/2 times 3 out of 8. I'm going to multiply my numerators. 1 times 3 is 3. 2 times 8 would be 16. So there's a 3 out of 16 chance of getting numbers on both of them that are less than 4. A red number cube and a white number cubed are rolled. The faces of both cubes are numbered from 1 to 6. What is the probability of rolling a 3 on the red number and rolling the number 3 or less on the white number? Well, there's 6 different chances, 6 different things that can come up on the first cube, and one of them is the number 3, so I've got a 1 out of 6 chance of rolling a 3. The second one, 3 or less, so that's 1, 2, or 3. So there's 3 chances of getting a number out of 6. So here I can do some reducing. I'll reduce that. I'll put 3 into there 1 time, 3 into there 2 times, so I get 1. 2 times 6 is 12, so I've got a 1 out of 12 chance of rolling a 3 on the red number cube and rolling a 3 or less on the white number cube. A white number cube and a green number cube are rolled. The faces of both are from 1 to 6. What is the probability of rolling an even number on the white cube? Well, an even number, first of all, there's 1, 2, 3, 4, 5, and 6. Well, 2 is even, 4 is even, and 6 is even. So there's a 3 out of 6 chance of rolling an even number on the first cube and then rolling a 3 or a 5 on the second cube. So there's 2 out of 6 chance there, a 3 or a 5. Do a little reducing here. This part is 1/2. This part is 1/3. 1/3 times 1/2. Numerators, 1 times 1 is 1. Denominators, 2 times 3 is 6. There's a 1 in 6 chance of doing that. Probability of dependent events. Dependent, these are events that depend on each other. If two events, A and B, are dependent, the probability of both events occurring is the product of the probability of A times the probability of B after A occurs. After A, that will change the probability of B. So let's look at an example problem here. There are 4 red, 8 yellow, and 6 blue socks in a drawer, all mixed up in a drawer. Once the sock is selected, it is not replaced. That makes these events dependent. Find the probability of reaching into the drawer without looking and choosing 2 blue socks. Well, there's 4 red, 8 yellow, and 6 blue. If I add that up, there's 18 different socks that could be selected. And I want to reach in there and know the probability of drawing a blue sock. So I've got 6 out of 18, or that's 1/3. Then after I draw that, the probability of reaching in and drawing another one, there's only 5 left. So there's 5 blue socks, and there's only 17 socks to choose from. So there's a 5 out of 17 chance of drawing the second blue sock. So I've got numerators, 5 times 1 is 5. Denominators, 3 times 17 is 51. That's 51. So 5 out of 51 is the probability of drawing my second blue sock. Okay, we're having a little technical problem here. Hopefully get that corrected. All right, now let's go on. There are 6 green, 9 purple, and 3 orange marbles in a bag. Once a marble is selected, it is not replaced. Find the probability that 2 purple marbles are chosen. Once a marble is drawn, it is not replaced. Makes these dependent events. So I've got 6 green plus 9 purple would be 15 plus 3 orange would be 18 different marbles I could draw on the first draw. And a purple one, that means 9 out of 18 are purple. So I've got a 1 out of 2 chance of drawing a purple one on the first draw. On the second draw, there's no longer 9 purple marbles, there's only 8. And there's no longer 18 marbles, there's only 17. So I've got an 8 out of 17 chance of drawing the second one. 8 out of 17, I'm gonna do a little reducing here. 2 go in there once, 2 go in there 4. 1 times 4 is 4. 1 times 17 is 17. So there's a 4 out of 17 chance of drawing 2 purple marbles in a row. 2 purple marbles in a row. All right. Thank you.